All right, so now we're getting into the real chemistry part of chemistry here. Before now, we've learned that atoms are small bits of elements. Elements have their own number of protons, and like otherwise, nobody cares about the nucleus. Then we learned about electrons and where to put all of our electrons. And that's important because it leads us to this, which is which atoms will combine together in order to make compounds and molecules, which is basically everything around you. Everything you can touch, everything you can see, everything you can smell, all of it is compounds and molecules. So if we know the number of valence electrons, we can figure out any atom and how it's going to react to any other one. So our major question for today is, how do we figure out how reactive an atom is? First of all, what the heck is reactivity? So, reactivity, sciencey definition, is the tendency of a substance to undergo a chemical reaction. That means how likely is it to react with something else and form something new. If it doesn't want to do that, we call it stable or non-reactive. If it does want to do that, we'll call it reactive or unstable. Most atoms are reactive. There's very few that are non-reactive. So what makes an element or an atom reactive? If it is close to having a full outside shell of electrons, that means it's more reactive. Notice I have the word closer underlined. That does not mean it's full. If it's full, it's not close to being full. It is full, so it's not close. It needs to be close to full. All right? So that means it has like 7 and not 8. That would be close to full. Keep in mind that most of your atoms and elements want to have a full outside shell of electrons. That full shell means it's stable. We call that the octet rule. An oct of that goes along with 8, like octopus, octagon, right? Stuff with 8. So it's called the octet rule because if it has 8 valence electrons, that atom's a little bit happier. Now keep in mind, hydrogen and helium have too small of a ring in order to fit 8. They can only fit 2, so they're happy with 2. So what that means is the most reactive elements ever are the ones with 1 valence electron or 7 valence electrons. The reason 1 valence electron is really reactive is if they can just get rid of that 1 electron, then that bumps them down to the energy level below, which would be full. All right, so in order for us to get that 1 valence electron on the outside ring, we had to have an inside ring that was already full. So if they can just get rid of that outside ring, the inside ring is full. Now they're a little bit happier. We call those the alkali metals. When we talk about the periodic table, we'll talk about our group names later. But those are the alkali metals. They have 1 valence electron, and they are extremely reactive. The other ones that are extremely reactive have 7 valence electrons. They just need 1 more in order to be happy. And guess what? They steal an electron from the alkali metals in order to get there. So one of the most common compounds of an alkali metal and a halogen is salt. Like the regular salt that you put on food and stuff. Table salt. Sodium chloride. Sodium is an alkali metal. It has 1 valence electron. Chlorine is a halogen. It has 7 valence electrons. So chlorine will steal that 1 electron from sodium. Now chlorine has 8. Sodium has 0 valence electrons. And now both of them are a little bit happier. But guess what? Now sodium, missing an electron, has a positive charge. Chlorine, with an extra electron, has a negative charge. So the positive and negative go together, and now we have sodium chloride, the compound. Atoms that are least reactive have a full outside shell. That group is called the noble gas group. Again, we'll talk more about them when we get our periodic tables together. They are not reactive at all because they're full. They don't want any more electrons. They don't want to get rid of electrons. They're happy just the way they are. They don't want to make friends with anybody. The ones that are less reactive, but they're still going to form compounds, are the ones kind of in the middle, like with 4 valence electrons. So they're less reactive than a halogen or alkali metal, but they're not nearly as stable as a noble gas is. So there's a nice little model we can use to show how some of these atoms get together to form their compounds. And they're called Lewis dot structures, named after some dude named Lewis. And what he does is he has the chemical symbol. I'll show you an example in a sec. And then he puts the number of valence electrons in dots around that chemical symbol. It's easier if I show you an example. So here's some of the examples. Carbon. If I look at carbon on the periodic table, carbon has 6 electrons. That means there's 2 on the inside ring and 4 valence electrons. So that means I would put my chemical symbol of C and 4 dots. 1, 2, 3, 4. 4 valence electrons around carbon. If I find beryllium on the periodic table, it has an atomic number of 4. That means it has 4 electrons. 2 electrons are on the inside shell. The other 2 are on the outside energy level, so that's the number of valence electrons. It has 2. If I look at neon on the periodic table, it has 10. 10 total electrons. That means 2 on the inside shell, 8 on the outside shell. That means it has 8 valence electrons. So I would put 8 dots around neon. So here's how Lewis dot things are helpful in imagining what elements might look like. Again, it's all imagination here. This is not like real life how things work, but it's a model, and it's a good way to help visualize how this stuff works. So let's talk about water. And most of you know that water is called H2O, right? That means there's 2 H's and 1 O. So the real question is, why 2 H's? Why not 3? Why not 1? Let's see if we can use some valence electrons to figure that out. Hydrogen on the periodic table is 1. That means it has 1 valence electron. I'm going to put 1 little white dot for hydrogen's electron. Oxygen on the periodic table is 8. That means there's 2 on the inside level, 6 on the outside level. So I'm going to make little pinkish orangey colors for the 6 electrons for oxygen. 1, 2, 3, 4, 5, 6. Now, keep in mind all the atoms want to have a full outside shell. Hydrogen is tiny. It only has 1 energy level, and that 1 energy level can only hold 2 electrons. So check out hydrogen right there. Does it have 2 electrons nearby that it can use? Sure can. If it shares that 1 electron with oxygen, now hydrogen has 2. If oxygen shares that 1 white electron with hydrogen, now oxygen has 7. Well, 7 isn't 8, is it? So is oxygen happy right now? Nope, it sure isn't. I need some other electron to add to my oxygen to make oxygen happy. So I need 1 more. I'm going to have another hydrogen with 1 more electron that they're going to share. So that hydrogen has the 2 electrons, it has a full outside shell, and now oxygen, if it shares those 2 electrons with hydrogen, has 1, 2, 3, 4, 5, 6, 7, 8 total electrons. Oxygen's more stable and happier now because it has 8 total if it shares those 2 with hydrogen. Hydrogen's happy because it has 2 total if it shares 2 of the electrons from oxygen. That's why water is H2O and not HO or H3O. All right, so here's the things that you should have learned today. First of all, atoms want to have a full valence electron shell. That's called the octet rule, even though if it's hydrogen or helium, they only have 2 and not 8. The closer the atom is to having a full outside shell, the more reactive it is. That means our 1 and 7 valence electrons are the most reactive atoms that we have. And atoms will either share or steal electrons in order to get their full outside shell. This is important because before now we learned about ape man, right? And that the atomic number is equal to protons is equal to electrons. But now we're learning not always equal to electrons. There are situations where electrons might have a different number. And if they're stealing electrons from each other, then that atom is going to have a different number of electrons. So most of the time, protons are equal to electrons. But every now and then, there may be an extra electron or a missing electron. So really, not always are protons equal to electrons. That's it for today. Good luck on your assignments. Make sure you're staying safe.